Well, folks, we've got a great big topic for us today. This is called the discriminant, and this is probably one of those topics that has a lot of memorizing. And in fact, you may even want to make flashcards for this one. So we've kind of talked about the discriminant yesterday. We said the discriminant is the part under the radical in the quadratic formula. It's that b squared minus 4ac. And we saw it pop up quite a bit yesterday in our notes, and we kept getting negative answers. But basically, there's 4 different cases you have to memorize. So like I said, you might want some flashcards handy. Exercise 1. For each of the following quadratics, calculate its discriminant, its roots, and state the number and nature, whether they are rational, irrational, or imaginary of the roots. So this has to go very neatly in your notebook. Here is case 1, and this is what we want in there. Case 1, the discriminant is a perfect square. And then we're going to go through and we're going to describe 3 things about it. So before I can find the discriminant, I have to identify my A, my B, and my C. So my A is 1, my B is 3, and my C is negative 10. So let's go get our discriminant. The discriminant is b squared, so 3 squared minus 4 times a times c. Okay, you can grab your calculator. That's 9 plus 40. I get my discriminant to be 49. Now, what's special about that in case 1 is the discriminant is a perfect square, and that's going to have some rules that go with it. Okay, so let's just make a note, PS for perfect square. Now, let's actually go get the roots. To find the roots, I just solve this equation. So I'll use my quadratic formula to solve this equation. So negative b plus or minus the square root. Now you already know what this turns out to be. B squared minus 4ac. We just found here. We got 49. All over 2a. Now as I clean this up, I'm going to get x equals negative 3 plus or minus. I know the square root of 49 is 7 all over 2. Now I'm going to stem my 2 answers. I get x equals negative 3 plus 7 all over 2, and x equals negative 3 minus 7 all over 2. So negative 3 plus 7 is 4 divided by 2. I get x equals 2. And this is negative 10 divided by 2. I get x equals negative 5. So those are actually my roots. Now here's the important part that needs to be very carefully noted in your book. Okay, you have to be able to describe in words the number and nature of the roots. So according to case 1, if the discriminant is a perfect square, here's what you have to memorize. You get 2 roots. Okay, and I just showed you that here. We got 2 roots that are unequal. They are real numbers. They're not imaginary. They're real numbers. You know the numbers 2 and negative 5. They don't have any eyes. And here's the key. They are rational. Alright, so this is, like I said, where those flashcards would come in handy. On one side of the flashcard, I would put the discriminant is a perfect square. On the other side, here's what I'm writing. 2 roots, unequal, real, and rational. Okay, now, let's get a graph of what that might look like. Basically, I have to cross the x-axis twice at 2 and negative 5. So here's my negative 5, here's my 2. And my parabola could either, go happy or sad, concave up or concave down. So all I know is I have a quadratic, a parabola, that has 2 roots that are not the same. They are real numbers, and because it's perfect, it's rational. And I guess that's one way I try to memorize it, is I try to think perfect people think they're rational at everything. So perfect, square, rational. Case 2. So again, case 2 in your notebook, and here's the rule. The discriminant is not a perfect square. So let's identify our A, our B, and C. Let's see, our A is 1, our B is negative 6, and our C is 7. So let's go get that discriminant. Discriminant equals B squared, so negative 6 squared, minus 4 times 1 times 7. I get the discriminant equals 36 minus 7 times 4 is 28. I get the discriminant equals 8. Now, is 8 a perfect square? No. So I'm just going to say not a perfect square, just so I keep that straight. Okay. Now we can actually go get the roots with the quadratic formula. X equals negative b plus or minus the square root. I know my discriminant is 8 divided by 2a. Now I get x equals 6. I have to break that radical down. It's not perfect, so 4 and 2. So I get x equals 6 plus or minus, that becomes 2 radical 2 all over 2. I can factor out the top there with a 2. I get 3 plus or minus radical 2 over 2. So I get x equals 3 plus radical 2 and x equals 3 minus radical 2. Okay? All right, now the fun part that we have to memorize. How many roots did we get? We got 2 roots, almost the same as last time, 2 roots. Are they the same number? Well, no, one's 3 plus, one's 3 minus, so they are unequal. Okay, nothing's changed from my previous one. They are unequal. Are they real or imaginary? Well, if you didn't get an I, they are real. Now, here's the only difference so far. Okay, if I'm a perfect square, we said the key word to memorize was rational, but if I'm not a perfect square, if you're not rational, we call that irrational. Okay, and that's the main one that's difference between those two. So if you get a perfect square, everything's the same except you're rational. If you're not a perfect square, everything's the same but you're irrational. Now again, what does that picture look like? Well, you have to have 2 roots, 3 plus radical 2 and 3 minus radical 2. Whoops, I think I graphed that in the wrong spot. 3 minus radical 2 would be here. And again, I just have 2 roots that aren't the same. But the idea is I'm hitting that x-axis twice. All right, stick with me. We got 2 cases left. Case 3, so this is in your notebook as well. And here's the rule. The discriminant is equal to 0. So b is equal to negative 10, a is equal to 1, and c is equal to 25 based off that equation. So my discriminant equals b squared, negative 10 squared, minus 4 times 1 times 25. That's going to get me a discriminant of 0. Okay? So now watch what happens with my roots. I get x equals negative b, so 10, plus or minus the square root of 0, all over 2. I get x equals 10, square root of 0 is just 0, 10 divided by 2. All I get is x equals 5. Okay? Notice, how many answers did we get? All right, now this is where this one changes significantly. We get 1 root. Okay, I only got 5. I did not get 2 answers because the plus or minus, it killed anything after it there because that was 0. I got 1 root. But here's the deal. The root is repeated. Okay, the root is repeated. I got 1 real root. It is a real number. It's not imaginary. And the key word we're going to memorize this time is equal. Okay, I know we got 1 root, but we are going to say the roots are equal because our discriminant is equal to 0. So here's what the graph is going to look like. Our root is 5. Okay, it can only hit the x-axis once, and it looks like that. It's basically sitting on the x-axis. And the way we describe that from your good old geometry days there is if you touch something once, we call this tangent to the x-axis. All right, if it's touching once, okay, it is tangent to the x-axis. It's just sitting on there. All right, so now this one was very different from the previous two. We got 1 real root. Notice it's real, it's not imaginary. It's repeated, and the roots are equal. And to me, that's a huge word. That's the word that's different from everybody else. The roots are equal when it's equal to 0. All right, last case, I promise you, case 4, and you've actually seen this one before. This one's called the discriminant is less than 0. I also like to refer to that as negative. The discriminant is negative. My a is 1, my b is negative 8, and my c is 20. So my discriminant is b squared, so negative 8 squared, minus 4 times 1 times 20. So I get a discriminant of negative 16. So notice your discriminant is negative. So what does that tell us about the roots? Well, I get x equals negative b plus or minus the square root of negative 16 divided by 2. Well, remember, because I get a negative under there, I'm going to get a what in my answer? You've guessed it, an imaginary number. Okay, so I'm going to pull out my 4. I get 2 plus or minus I all over 2. I get 2 times 2 plus or minus I, which I can say is 4 plus or minus 2i. I get 2 answers, but this time I get imaginary numbers. So I just want to be clear, I get 2, okay, and we're going to call them complex roots. Complex roots or imaginary numbers, okay, 2 complex roots. The key is that they are imaginary. And we talked about this yesterday. If they're imaginary, there are no x-intercepts. They do not touch the x-axis. So that means this graph it's a positive x squared, so I know it looks something like this. It has 0 x-intercepts. It is not touching the x-axis. So we understand that was a lot to take in, but you're going to use those notes for the next few examples here. It says, by using only the discriminant, determine the nature of the roots. And that's typically the question. Okay? Determine the nature of the roots. They usually don't say use the discriminant. They usually just say talk about the nature of the roots. All right? Nature of the roots is your key word. So I've got to know when I see nature of the roots, that implies the discriminant formula. So I'm going to say b squared minus 4ac. All right, and I'm going to equals my discriminant, and I'm going to see what I get. My a is 2, my b is 7, my c is negative 4. So I'm going to say my discriminant equals 7 squared minus 4 times 2 times negative 4. All right, and you don't need to do anything else but go to your calculator and type that in. And I get a discriminant of 81. Okay, now based off that, you should be able to describe the roots. So what type of number is 81? Well, in my head, I say, okay, that's a perfect square. And now I either go back and I look at my notes and I see what it said about perfect square. I have these memorized, which is our goal here. A perfect square, the 81 is clearly a real number. Hope you would agree with that. It's not imaginary. Because it's perfect, the key word is rational. I get 2 roots that are unequal. Remember, I'm only using equal if I see 0. And those are the 4 words we need to memorize. Real, rational, unequal, and I get 2 of them. Okay, let's try the next one. My A is 1, my B is negative 8, and my C is 25. Okay, so let's get our discriminant. B squared minus 4 times 1 times 25. So just go to your calculator, figure out what you have. See, I get 64 minus 100 is negative 36. Okay, and to me, that's the easiest one. The second I get a negative, I am using the word imaginary. Okay, I have imaginary roots. That means they have 0 x-intercepts. They are never going to cross the x-axis. Okay, imaginary roots, 0 x-intercepts. So they're not real. They're imaginary. I don't have 2 of them. I have 0 of them. And that's pretty much all I need to know, and pretty much the graph. The graph, because it's a positive x squared, is sitting above the x-axis. Next one. My A is 4. My B is 4. And my C is 1. So my discriminant is B squared minus 4 times A times C. So I've got 16 minus 16. I get a discriminant of equal to 0. All right, so I say to myself, 0 is a real number. Okay. Because it's equal to 0, this is the one and only time I use the word equal. It has equal roots when it's equal to 0. Okay, that means it's tangent to the x-axis. Okay, so let's get a little sketch in there. It's sitting right on the x-axis. It has the same roots. Maybe it's 5 and 5 or 6 and 6. They are sitting right on the x-axis. So the key word is that they are real and equal and tangent to the x-axis. Okay, a couple more to practice. Let's say our A is 1, our B is 6, our C is 15. So I'm going discriminant equals B squared minus 4 times 1 times 15. I get a negative 24. Negatives are my favorite ones, of course. The second I see a negative, I'm writing down the word imaginary. Okay, so it's not real, it's imaginary. And that tells me there are no x-intercepts. So that graph, if it's a positive x squared, it's smiling and it's above, completely above the x-axis. Let's see, our A is 1, our B is negative, whoops, our A is 4, not 1. Our B is negative 4, and our C is negative 7. All right, so my discriminant is Negative 4 squared minus 4 times negative 7. So grab that calculator. And I get a positive 128. Okay, so the first thing I say to myself, is it perfect or not? And I'm going to say this is not a perfect square. So it's still a real number. Okay, it's not imaginary, it's not negative. If it's not perfect, the key word you have to memorize is irrational. Okay, I'm unequal, and I have 2 roots. All right, so I'm just using that chart we made. I'm real, I'm irrational, that's my key word, unequal, and have 2 roots. Last one, my A is 3, my B is negative 7, and my C is 2. So my discriminant equals negative 7 squared minus 4 times 3 times 2. I get a discriminant of 25. Okay, I love that number because that is a perfect square. So I'm getting a real number. Because it's perfect, my keyword is rational. I get 2 unequal roots. Okay, so I'm crossing that x-axis twice, just at 2 different numbers. Exercise 3. Consider the quadratic function whose equation is y equals x squared minus 4x plus 4. Determine the number of x-intercepts of the quadratic from the value of its discriminant. All right, so let's start with our discriminant. Is b squared minus 4 times a times c. In this case, my a is 1, my b is negative 4, and my c is positive 4. So let's see, I get negative 4 squared minus 4 times 1 times 4. That gets me a discriminant of 0. So let's jot down what we know about our rules of 0. 0 is clearly a real number. When it hits 0, this is the one time I use the word equal. Every other time I'm using unequal. And what's special about this one, we said, is that it basically has a 1 repeated root. 1 repeated root. So now it says, we say this parabola is tangent to the x-axis, and we've talked about that. This parabola is sitting on the x-axis. Now we can actually solve to get our root. So let's say x equals, let's see, negative b is 4, plus or minus, I already know my discriminant is 0, divided by 2. So I get x equals 4 divided by 2, x equals 2. So I can graph this very easily. I'm going to go out to 2. There's my point. And again, it's a positive x squared. That means it's opening up. I'm sitting right on the x-axis, tangent to the x-axis. Exercise 4. So here's a typical multiple choice question. Which of the following parabolas has 2 unequal rational x-intercepts? Out of all the words sitting in there, there's one that's jumping off the page at me. Hopefully it's jumping off the page at you too. And that's the word rational. If I'm rational, I only use that word once, and that is when I have a discriminant that's equal to a perfect square. And that's why we got to start to memorize these. They're just going to give us these descriptors, and you got to know what it goes with. Remember, rational is perfect square. So I'm just going to take my discriminant of each one and see which one has a perfect square. So in option 1, all right, my A is 1, my B is negative 2, and my C is negative 1. And I'm going to go through my discriminant. So my discriminant is b squared minus 4 times 1 times negative 1. That gets me 4 plus 4. That gets me an 8. Is 8 a perfect square? I would say no, so that one's out. Let's go to choice 2 here. A equals 1, B equals 2, C equals negative 15. My discriminant is b squared minus 4 times 1 times negative 15. So I've got 4, b squared is 4 minus 4 times 1 times negative 15. I get a discriminant of 64. Is 64 a perfect square? Well, ding, 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 we have our winner there. If I get a perfect square, I know that means I have a rational root, and I'm going to go with choice 2. Example 5. For what values of a will the parabola not cross the x-axis? All right, now this one's a little sneaky. You got to think about this. If your graph does not cross the x-axis, okay, what do you know about its discriminant? Okay, well, I know if I'm not touching there, the roots are imaginary. And if the roots are imaginary, that means that the discriminant is negative. Okay? So I need to figure out how to make my discriminant negative. So I'm going to start with b squared minus 4ac. And I'm going to say if it's negative, that means this number has to be less than 0. Keep that in mind. If I'm negative, I'm a number smaller than 0. So in this formula, my a is equal to a, my b is 4, and my c is 2. I'm just going to carefully substitute those in. So I've got 4 squared minus 4 times a times 2. And I know that needs to be less than 0. So 4 squared is 16 minus 4 times 2 is 8a, and that needs to be less than 0. I'm going to say negative 8a is less than negative 16. Just subtracted my 16 over. And I'm going to divide both sides by negative 8. Now the only bear trap is when you divide by a negative, you've got to flip that sign. So I will get any number bigger than 2 will get me a discriminant that's negative. So let's talk about some numbers that work. Would 1 work? Is 1 bigger than 2? No. Would 2 work? Is 2 bigger than 2? No. The first whole number that would work would be 3. But there are other numbers. Remember, 2.5 is bigger than 2, 2.1. But basically any number bigger than 2 will work. Well, folks, that's going to do it for us tonight. There's lots to memorize there. So like I said, come with those memorized, make yourself some flashcards, do what you need to do to get those rules down. Have a great night, and we'll see you tomorrow.